4.7 gives us yet another way to solve quadratic functions, and that is to find where the function crosses the x-axis. So this lesson we'll learn how to solve quadratic equations using the quadratic formula and to determine the number of solutions using the discriminant. Before we can use the quadratic formula, we need to make sure that the equation is in standard form. Then we can plug the coefficients into the following formula. Negative b plus or minus the square root of b squared minus 4 times ac all over 2a. If we use the tune of Pop Goes the Weasel, we can turn the quadratic formula into a song. It goes like this. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you listen to that a couple times, I promise you for years to come, whenever you hear of the quadratic formula, you will remember that song. Plus, it'll be helpful to not have to reference your notes all the time on doing your assignments. The first quadratic is already in standard form, so now we can identify our a value, b value, and c value. Remember, a is really a positive one, b is 2, and c is negative 7. Always remember to attach the sign with the number. Now we can plug them into the formula, which says it's negative b, so we're going to plug in 2, plus or minus the square root of b, which is 2 squared, minus 4 times a times c all over 2 times 1. Now before we go further, we're going to want to use order of operations and work underneath the square root. So 2 squared will give us 4. Negative 4 times 1 times negative 7 is positive 28, which then gives us 32. So if we rewrite this, we're going to have negative 2 plus or minus the square root of 32, all divided by 2. Now we're close to having our final answer, but we need to remember that we always simplify underneath that square root when possible. That means we need to break down the 32 into what numbers multiply back to it. We could use 8 and 4, but then we could break down the 8 even more into 2 and 4. Well, now we have a pair of the same number that we can pull out. The 4 comes outside of the square root, and inside we're going to leave what's not circled, which is just 2. Rewrite everything else, so we'll have negative 2 plus or minus all of that divided by 2. Since we have addition on the top and we're dividing by the same number, we could rewrite this as two separate fractions. Negative 2 over 2 plus or minus 4 square roots of 2 all over 2. Then we can divide to simplify. That leaves us with negative 1 plus or minus 2 square roots of 2. And there is our final answer. Now do notice that we only divided the numbers outside of the square root together. We cannot divide the number underneath the square root with the number in the denominator, which is why we still have the square root of 2 in our final answer. For the second quadratic, I want you guys to pause the video, put the equation in standard form, then plug it into the quadratic formula. Then come back and check your final answer. This problem has the exact same steps as the last one, but this time we do have a negative b value. So make sure you're always plugging in your terms in parentheses. So that way we really end up with a positive 5 plus or minus the square root of 13, all divided by 2. And here is our final answer. Now let's try applying the quadratic formula. Let's say your school jazz band is selling CDs as a fundraiser. The total profit P depends on the amount X that your band charges for each CD. The equation given models the profit of the fundraiser. What is the least amount in dollars you can charge for a CD and make a profit of $200? Let's look at some of our key words here. First off, we know that profit is represented by P. We know the amount that they sell the CDs for is represented by X. We want to know the least amount that you can charge for a CD, and we know the profit needs to be $200. Well, this means that we know what one of our variables is. We know what P is. So we can plug that into the equation that's given. So we're going to plug in P, and then we're going to need to put it in standard form. That will give us 200 equals negative x squared plus 48x minus 300. Subtract 200 to each side. So 0 equals negative x squared plus 48x minus 500. Well, now this looks exactly like the problems we were just doing. We can apply the quadratic formula. So A will equal -1, B equals 48, and C is -500. Plug that into the formula. We're going to have -48 plus or minus the square root of 48 squared minus 4 times -1 times -500, all divided by 2 times -1. Simplifying here underneath the square root will give us the square root of 304, and since we're trying to find dollar amounts, we just want to turn this into a decimal, which is approximately 17.4. So now we have one solution, which is -48 plus the 17.4, all divided by a -2. The second solution would then be -48 minus 17.4, also all divided by -2. On the first one, we'll add that. We'll get -30.6 divided by -2, which is 15.3. On the second one, we get -65.4 divided by -2, which is 30.7. Well, remember the question asked, what is the least amount that you could charge? Since 1530 is the smallest, that will be our solution. They need to charge at least $15.30 to make a profit of $200. Next, we have what we call the discriminant, and this uses a portion of the quadratic formula to help us find the number of solutions we're going to have. The discriminant is just this portion underneath the square root, but it does not include the square root. So it's really just b squared minus 4 times ac. When we plug the values into the discriminant, if the solution we get is greater than 0, then that's going to tell us that we have two real solutions. In terms of x-intercepts, that's going to mean that we cross the x-axis 2 times. With a graph like this, or we could have a graph that goes down and crosses 2 times here. If the value of our discriminant ends up equaling 0, then that means that we have one real solution. And the graph would look something like this. It touches the x-axis one time with its vertex, either opening up or opening down. But if our discriminant ends up being less than 0, then that tells us that we have no real solutions. Meaning that our parabola is going to open up or it's going to open down, but it never crosses the x-axis. Now let's use the discriminant. Just like the quadratic formula, we do need to make sure that it is in standard form first. So in the first example, we can subtract 2 to both sides, leaving us with -2x squared plus 37x minus 8 equals 0. Well, now we know that A is -2, B is 37, and C is -8. Again, always remember to include the sign of the number. Now we can plug this into the discriminant, which tells us we need B, which is 37, all squared, minus 4 times A, or -2, and C, -8. This becomes 1369 minus 64, which is 1305. So here is our discriminant. Since it is greater than 0, that tells us that we will have two real solutions. And then also remember that two real solutions means that we are going to have two x-intercepts. The next example is already in standard form for you, so you just need to identify A, B, and C and plug it into the discriminant, and then use your table above to interpret the number of solutions. Go ahead and pause the video. For this quadratic, the discriminant is a negative, which tells us that there are no real solutions. And because of that, that means we have no x-intercepts or we are never crossing the x-axis. This is setting us up for tomorrow's lesson, where we are going to learn about imaginary solutions if there are not real solutions. Now we can use a discriminant to solve problems. Let's say that you hit a golf ball in the air from a height of 1 inch above the ground with an initial vertical velocity of 85 feet per second. The function is given here, and it models the height in feet of the ball at time t in seconds. Will the ball reach a height of 115 feet? We need to start by identifying our known information. It gives us the starting height of the ball as well as its velocity, but if we look at the equation, h represents the height and t represents the time. Neither of those values are important to solving the problem. We want to know, will the ball reach a height of 115 feet? Now notice it's not asking us to solve the actual problem. We just want to know if it will reach this height. That means all we need to do is find the discriminant instead of using the entire quadratic formula. But before we can find the discriminant, we do need to make sure it is in standard form. Like the application of the quadratic formula, we do need to start by plugging in the h value, and then we're going to put it in standard form. We will plug in the 115 for h. That will equal negative 16t squared plus 85t plus 1/12. Subtract 115 to both sides, so 0 is equal to negative 16t squared plus 85t minus 114.92. Now that it's in standard form, we are able to find the discriminant. We know that A is negative 16, B is 85, and C is negative 114.92. That will give us 85 all squared minus 4 times negative 16 times negative 114.92. This simplifies down to negative 129.88. So the last thing that we need to do is to evaluate. What does it mean that we have a negative discriminant? Well, negative discriminants tell us that we have no real solutions. Therefore, the ball will not reach a height of 115 feet. If we had gotten a positive discriminant, then that would have meant it did reach that height.